where a project starts from, and how we take the conceptual planning into detailed development. So I'll talk about the conceptual stage to the development to the final architecture, because that's very important for a architecture student to understand that how on a barren site a form takes shape. And it's not just the building form that is important, but it's how we tackle the site. And then we finally go into the architectural detailing, and everything put together is what we call architecture. Now in site planning, that is, the site is what we start with. I would like all of you to tell me quickly in the chat box. I feel there are four parts of a site planning. Firstly is the concept. Now, how many of you agree with that? Those of you who agree, put an A. Those who feel it's not so important, put NA. Not agreed. So I've got my chat box open. I'd like to have all your responses so that I know that you all are there with me on this. Yes, Ritik has, Richa Goswami says yes, Nikita, Roli, Chaudhary, thank you. Thanks everyone, Naveen. I see a highly responsive class here and very, very intelligent and bright students. Yes, of course, conceptual planning is the most important thing. Another aspect which is very important when we get down to the site is the topography. How many of you will agree to that? That topography also has to be taken care of. So those of you who agree can put A. Thank you, Snigdha. I'll wait for everyone. Yes. So all of you are with me on this. Thank you so much. A very, very receptive class here. The third aspect is also the climate, which is often neglected, because climate is something that, if neglected, can make the whole project unviable, can make it unsustainable. So how many of you feel that climate is also an important factor? Can write A. Okay, thank you. Thank you so much. And finally, we have the brief. That is the project program, we call it, or project brief. So these are more or less broadly four components. We have other aspects also. We'll look at materials, we'll look at people. But when we come to the physical planning, initially, these are the four broadly things that we start with. Now tell me, what would be your uh, preference, or what would be your importance? Say, for example, the four things that I named: concept, topography, climate, and the brief, or the project program, let's call it program. So what would be the sequence? So you can write C for concept, T for topography, CL for climate, and the program for P. In what sequence will you put it? Will you look at the program first, or the climate first, or the topography first, or the concept first? So you can have C, T, CL for climate, and P. I mean, there is no one correct answer. Write all four. What would be the sequence? Concept first, then climate, third topography, fourth P. So it can be C, T, CLP, or P. Someone of you, yes. So Sneha says the program, then the climate, then concept, then topography. Okay. Jen says climate, program, topography, concept. Right? So all of you are correct. There's no one correct answer in this. But yes, all these four are equally important. And what we look at most importantly is topography. The first thing that should, yes, Kartikeya, thank you for that. And Saket also has written the topography, which leads, and then climate, because these are things which are already there at site. The topography is something that is part of the site. It's not put in. The climate is already there. Concept and the program is something that we bring into the site. So let's look at topography first. How does that dictate the layout? Because your concept and program, let's imagine that the concept is something that will be an outcome of your response to the topography and the climate. And of course, the concept will fulfill the program. The project brief will be fulfilled. That's no doubt. That's part of any architectural design. But certain intangible things, concept and climate and the topography. Why the topography and the climate are important is because today when we talk of sustainability, these are two very, very important aspects of a site which are often overlooked. So sometimes a project can look very nice, can be very nicely resolved, can look good, can function very well, but if it has not taken care of the topography or the climate, then it will start facing issues like flooding. If you are building in the hills, there will be avalanches, there'll be landslides, walls will collapse, all these problems happen. So I wanted to show you the two particular projects, and I hope that will quite easily demonstrate all these four aspects of design before you go into the final detailing of the design. Now, this is a site in Pahalgam. This is when I first visited in 2015, almost 6 years ago, 2014, yeah, almost. And there was still quite a bit of insurgency in that area. And so you can see the site which was like a park, and there were some small huts that were existing. There was an old Pahalgam club that had been burnt down and they wanted to build it afresh. So when I first visited the site, you can see this site slopes down towards the river. Any site naturally will slope down towards the river. On the other side of the river are the hills. This is the Lidar River. It flows throughout the year, and this is the flow usually. And as you can see, the river flows from the right to the left. So there is a gradient of land from the right towards the left. Plus there is a gradient. It might seem that the site is flat. All of you who can see this photograph will feel that the site is almost flat. But of course, there is a slope. The land slopes gradually down into the river. So my first visits of the site, this is the river in spate. Me without the beard, 6 years back. And that is the little hut on the side that existed, which was like a site office. And this is a jetty on the left, and on the right when it was redone, because the old little jetty was almost rotting. And we said, let's erect it back. So one photograph is downstream so that you can see the whole length of the site. And the other photograph on the right is upstream where the river comes in from. So on the left, now we had a site which was almost about 5 acres. Now you see now on the left, the sheet which is having the form and the spatial evolution, the concept, what we call. So the first thing, like I said, topography, because it existed, we had to take care of the river sloping, the land sloping towards the river, and also the land sloping downwards according to the flow of the river. So there was almost a 3-meter slope on either side, both the sides. You can imagine from the road on the right till the river on the left, the road sloped about 3 meters, and even vertically from the north to south, there was slope downwards towards the south about 3 meters. Now on the left was our concept. When we first visited the site, there's a road and there's a river. And we had to look at site drainage. So there were two aspects that we introduced in this as a concept. So first was the topography, how to take care of the drainage. So we decided to create a small network of canals, which would be used for rainwater harvesting. Now, in architectural design, there is something called expressionism. There is structural expressionism, or even in landscape or in plumbing, whatever we design, we can use it as an element and express it at the site. So here we decided that we will not hide the rainwater canals, rather we would use it to celebrate water, to show water as an element. So there is this thin grid that you see. Those are the rainwater harvesting canals. And on the right, we diverted a little bit of the river to go through the site, and it joins back the river after going through the site. So the central canal that you see on the left below is a photograph of that left below. Now I'm explaining it to you on the right, the photograph on the right. So you see in the center of the club flows the river. Now the evolution of the concept came from first the topography. Now look at the left side image. You have the river and the blank site. The second one was the decision to use the river as an element that could act also. The river would be taken through the site and made into a canal, a broad canal, and that will also be fed by the rainwater harvesting canals of the site, and that will fill up this canal and it will flow back into the river. The third image on the left hand side image, the number 3, it shows gradually from the topography we are then looking at climate, because this receives a very, very heavy rainfall, Pahalgam, and also very heavy snow. In winters, almost you get a 7 feet of snow. So we also had to devise ways where all the snow would melt and get into the canal. The snow also slides off from the roof, collects on the ground, melts, gets into the canal and flows out. So topography and the climate led us to this concept. And in the third stage, once we had the grid and the network of canals, then we decided to have our forms situated around that canal. So the concept in this case was dictated by the topography and the climate. Of course, when we went into the detailing of the concept and the program and interpretation of the brief, then the functions came about. Then we looked at materials, why exposed brickwork, locally available, the traditional Kashmiri vocabulary, which uses daje devari. In a seismic zone, you see this wooden lattice, the cross wooden lattice, lattice work that you see on the buildings was inspired by the local traditional architecture of that region. Now, if I see the contours, now this is a slightly more detailed level after the initial concept, which I showed in the previous slide. Now we come to a slightly more detailed concept where you can see on the extreme right, we brought in the river. And of course, this is not always possible to do this. We were lucky because this was a government project. This was a Kashmir tourism project, and they had floated a competition. It was a national level competition with Kotaris and even big companies like CES and Kanvindes joining in. But we won the competition just on the basis of this concept. No one had used the river or thought of the river. Everyone had made their club looking towards the river. So we had the club looking towards the river, plus towards a river which was flowing through the site. I will show you later on images. Now in this, you can see the river on the north and how the river forms a central canal in between, broadening out where the other channels come and meet. And then it drops gradually because the water cascades normally, because as you know, the slope is from the right to the left. And then through the canal and the network of rainwater harvesting canals and the central canal of the river, what we created, we realized we were getting 4 quadrants around the site. Now that dictated how the project brief would come up. Now, if you see, let me see if I can annotate and draw on this. No, I'm not able to access my pen. No, otherwise, anyway, I will explain from bottom left of quadrant was the main arrival, the reception with a banquet hall, with a conference room, a restaurant, a bar, and the main administrative facilities of the club. And you had to cross this canal, go over a bridge and reach the other part, which is the top left, which was used for the main big conference center. This is a conference center of for about 300 people, and it was flanked by certain games room, certain conference facilities, and a banquet hall as well. On the right top was the accommodation. I'm sure you can make out. There is an accommodation, small rooms. We had about 12 rooms below and 12 rooms on the top, about 24 rooms. So about 50 people could stay here at a time. And then there is another structure on the right of those rooms. That's where uh, the dining hall for all the rooms was located. The bottom right was where the other facilities, a swimming pool, a bowling alley, there was a gym, there was a spa. So all these came about. So very clearly, the topography taken care of first. Secondly, the climate, which dictated a lot of rain and snowfall. So created that canal in between to take care of the surface drainage. And then the project program led to this concept that we distributed the functions into 4. And because this was a fairly large site, we had to look at ways of execution. So when you handle a very large site, I'm sure a lot of you will be doing in your thesis stages, larger institutions, try to, from a presentation point of view also, arrange them into blocks which can be comprehended very easily. Even later on, when you send drawings to the site, it's very easy. You have administrative block at one place, conference block a second place, a third place is your accommodation block, and a fourth place is your, let's say, the resort block, the club block, right? And of course, then the parking comes in. If you see, this is where the gate is, where my mouse is right now. We created a slightly VIP parking on this side, extreme left, on the right, and then further on the right, more parking. So this was the basic how from the site, which I explained with the contours, how we took care of the topography, because surface drainage is very, very important. Even if it's a gradual site, whenever you handle a large site, if there is water stagnation within the site, it can create a lot of problems. So please look at surface drainage. It is often ignored. A lot of architects feel that, it's a plumbing consultant's job to design the surface drainage, but no. In this case, the plumbing consultant came and he decided maybe the fall, the size of the canal, the depth of the canal, how much water it would hold, what would be the flow rate. But we had already provided for the canal and these rainwater harvesting systems. We had already provided for that in our design. Now going to the next level plan here. Now I have slightly more, this stage is a slightly more detailed plan where you can see the masses. There were 4 blocks which looked totally independent blocks, but now you can see those connections being formed like small bridges. All the blocks get connected to each other. Only the residential block was later connected, so that bridge is not shown here, but the residential block has also been connected now, the one on the right. That block right now in this earlier plan is not shown connected. And this is something that in an abstraction, you are able to see how the whole plan has evolved, right? Now, any questions till now? If you are clear, say a yes with a Y, or if you are not clear, you can write NC. If you are clear, you can type yes. I'll wait for your response from everyone so that I know that you are following what we are talking about. Thank you. Yeah. Good, very responsive class. I love that. Thank you for your response. Yes, yes, yes. I won't mind if you have questions. You can always raise your hand, or we can take up the questions at the end. All of you have different sites. Each site will present different peculiar questions, so we can handle that at the end. This is again another detailed plan. In the previous one could see only the massing, the blocking. Here I have this plan shows you also the rooms, how the rooms and spaces respond to the conceptually, how it responds to the climate, topography, and the land and the canal. And I will show you finally visuals of what this eventually looked like. So a question from Javed, that how would you tackle the flood problems on the site? Now, if you have a very, very efficient surface drainage problem, there will never be a flood. Let me tell you, the way nature is built, there would never be floods anywhere. It is only the human hand that we design, where we do not take care of the surface drainage, where we block all the natural drainage canals. Jammu got flooded a few years ago, you would be knowing. A lot of cities get flooded. Even Delhi gets flooded sometimes. It's because we have blocked the natural flow of water on the land. If you see Delhi about 100 years ago, you would see that the entire land slopes down into the river towards the Yamuna. But now there are no canals, no network, nothing that leads to the river. So every city, whichever experiences floods, Mumbai, 200 years back, there were no floods. Even 20 years back, 30 years back, no one heard of floods in Mumbai. Floods are caused only due to insensitive planning, zoning, even at the master plan level, where we have not provided for surface drainage. You can imagine every land, imagine how the earth came into place or centuries ago. If you see Google maps of a few centuries ago, you will see that the land naturally slopes into the rivers, and the rivers are connected to the sea. That's how the all the rain, some of it which falls on certain depressions, form lakes. Somewhere it forms rivers, reservoirs. Somewhere it might form ponds. But the way the land has been prepared by nature, the flooding cannot happen. That's how rivers are formed. Okay. Now this is a detailed landscape plan where you can see the access road, the parkings coming up, more detailed, that the entire site, even from the south side of the plot, there's a narrow drain which slopes down, and even they are traveling in all the directions, and everything joins to the main canal. And I'll show you the photographs of the project, how it joins the main natural canal, and then it goes back and joins the river on the left hand side. There's a big park here, and then it goes through the park and joins the river further downstream. Now, how many of you feel that this is an appropriate response to the site or to the program, as well as the topography? If you agree, you can say yes. You can disagree also. I would love to respond or answer to some of you. If you felt in any way, no, there could have been a better response, yes, I'm sure there could have been. So those of you who agree that yes, you have followed so far, please type in an A so that I know that you are following the whole thought process behind developing a concept. When you start a site, how do you take responses from the topography and the climate to create a concept? A lot of us struggle with the concept, but the site itself will give you the concept. The site itself will tell you which are the sites which have the best views. How can you create good views? And this is during the construction. And you can see the canal on the outer rainwater harvesting canals, how they are being excavated without disturbing the topsoil anywhere. The canal has been excavated. And this is one of the rainwater harvesting canal. These are the rooms on the right hand side which overlook the river. And on the back, it overlooks the internal canal, the harvesting canal. This, as you can see, is a small rainwater harvesting canal. And this photograph is taken almost a little after the monsoons. This one fills up. Even if the river is not connected, this is the main canal which flows through the club. And it is a perennial kind of a canal. And this had just rained. You can see that the soil is also wet around, the grass is wet, and the walls are also wet. The RCC walls are still wet because of the rains, but there is not even a bit of flooding anywhere. This is the flow of water through the canal. through the site, and it becomes a feature all through the site. So the concept was to be able to see the river, to feel the river, smell the river. We have all five senses. A good architecture is something that involves all your five senses. You can hear the nature, you can see it, you can smell it. Well, you don't taste it, but I think the most beautiful thing is if it arouses four senses of yours, then you automatically feel your fifth sense is also aroused. This is another view, and that is one bridge which connects the two blocks, and the river flows through the main canal, and perpendicular to that you can see a smaller canal coming in, and that too dropping a bit. Can you see the difference between the levels? We created these RCC walls and canals. You can see the left hand part building and the bridges staggered and stepping down. Can you see the difference between the land? Almost a meter here, further down another meter, and that helped us create, small river, along the central canal, small reservoirs where the water collects, because suddenly when there's a lot of flow of water coming in from all the sides, it collects at one point, then it flows down. Now I'll talk about another interesting site. This is in the hills of Uttaranchal. Uh, Unfortunately, the working drawings were not available. I'm using mostly presentation drawing, but you can make out the steep slope of the land. You can see very dense contours. This site is flanked by two drains, on natural drains on either side. Whenever you see very dense contours on the left hand side of the plot, you can see very close contours. It means that there's a drain here. On the other side are also, on the right side of the site, also a very steep drain, and the contours will tell you, if you see the contour plan, there's a fair amount of slope. So what was the concept? Again, the initial site planning stages, we decided uh, to provide access to all the villas. Now this is a section of the site. Now you can see in the section how we have cut and filled, but used the existing landscape without flattening the land totally. Somewhere where the land slope was huge, we could create two levels, but mostly it's one or two levels. Somewhere it has gone up to three levels. This is the final outcome of what the site looked like after it came about. And this also ensured how you design will also ensure how you are exploiting the views. That the lowest level of villas, they overlook the valley. The villas on the upper level, they overlook over the roof of the other villas. And because of this, the slope of the roads have been created in such a way that the water drains off towards the two canals. We had a challenge about how to drain the water which is within each plot or site. Now, this is a view from one end looking towards the valley. And you can see even in the landscaping below, there are three terraces defined by retaining walls. One very interesting concept that we did was in this, that we decided to uh, again use the element of water to fill up create small canals. Now these white pebbles that you see here are actually rainwater harvesting canals. Now, of course, this site did not have a river or a stream or anything. So whatever rain that came from the roof comes and travels through these pebbled things. So during the monsoons, they fill up. You can see the water gently flowing through that. And in peak summers, when there is no water, it still is an interesting element. It keeps, and the water, if where my mouse is, if you can see there, we created small lily ponds where the water collects. Then it overflows into this little pebbled square platform, which is connected underground to another platform. Then it goes to the lower one, and it collects in rainwater harvesting pits, which are at the lowest level. In between, we created walking tracks. There's very little, if you see in this landscaping, something which is very important is to reduce hard surfaces whenever we do landscape. There has to be the right mix of how you treat your softscape and the hardscape. So as a sustainable architect, we use maximum amount of rainwater harvesting systems. In fact, the entire streets, this is a street, and you can see how the roof profile, they are getting the maximum south sun. In this case, the skylights have been created. Those are details that come later when you do architectural design. And all of them have views of the valley. On the south side, there are retaining walls. Towards the north is your view down the valley. Small elements like this little letter box, red one, is actually shaped like a bird, inspired by a bird. But what I wanted to point out here was the street. The street is made up of interlocking pavers, which are called grass pavers. Okay, Madhur has a question. Yes, some of your students have visited this site. Rajkumar, yes, I know they went to Brooks in Bhimtal. Okay, Madhur had a question. Is there any mechanical system used to pump out the water from the river to the site in case when the river is not full of water? So this is pertaining to the Pahalgam site, I guess, Madhur. I will come back to this. Okay. Now this is the street I wanted to show you, and how one can differentiate the car parking areas. And you can see that even the car parking area is made up of grass pavers. So every villa has lawns where the roof drains off, and then also this interlocking pavers. The streets are made with interlocking pavers. The parking area is designated by a different color of tiles, which is red. The streets are kind of earmarked by yellow color. And if you see the surface drainage system, as I was telling you, there are retaining walls, and you can see there are small weep holes. I selected this site. I thought sometimes if someone takes a steep site, how to handle it. Now these weep holes, they overflow and fill up this lily pond. Right now there are lilies growing inside this pond. And this, when it overflows, you can see there's a little bit of cut on that RCC tank. It overflows into this white pebble little courtyard, which is connected underground with this. When this fills up, it goes into this one on the right, and then it goes into an underground tank, which is on the right. We don't see it here, but you see there is no hard surface here. People can walk across these pebbled, which is also very nice in terms of, acupressure principles. This is very nice for walking on top of them, and it becomes a part of your landscape. We have used contrasting white large pebbles and very small gray kind of pebbles all over.